So my topic is determination of temporary and permanent hardness of water sample and also total hardness of water sample by using ADTA method. But before going to see the ADTA method is one of the titration. The name of the titration is complexometric titration. Here complexometric titration is also called as complexometry. Complexometry is nothing but measuring temporary, permanent and total hardness of given water sample by using complex compound. That is mean by the complexometry or complexometric titration. Now let us see the basic principle involving in the complexometric titration. This is a complexometric titration in which EDTA is used as a complexing agent. So here the complexing agent is the EDTA. This EDTA is using to find temporary, permanent and the total hardness of given water sample. So here EDTA is a hexadentate ligand, but whereas disodium salt of EDTA is a tetradentate ligand. So here I have given the structure, that is a disodium salt of EDTA, because in our titration we are using disodium salt of EDTA, we are not using EDTA because EDTA is insoluble in the water, but whereas disodium salt of EDTA is soluble in the water. So now I said that disodium salt of EDTA is one of the tetradentate ligand. Tetradentate is nothing but 4 donors are present in the ligand. So here 4 donors are, this negative charge is acting as one donor. This unpaired electrons on the nitrogen also acting as a donor. So here one negative charge, 1, 2, 3 and 4 donors are present in the tetradentate ligand, that is a disodium salt of EDTA. The full form of EDTA is ethylene diamine tetraacetate. This is one of the ligand, and this ligand is reacting with metal ions in the given water sample. Here metal ions in the water sample are calcium plus 2 ions and the magnesium plus 2 ions. So these metal ion is forming a complex compound with our EDTA sample, that is the EDTA complexing agent. So finally we will get one of the complex compound in the complexometric titration. So now let us see the basic principle. EDTA is one of the hexadentate ligand, but we are not using EDTA here, we are using disodium salt of EDTA. And this EDTA forms a stable complex with metal ions only at the pH range 10. That means this metal EDTA complex is forming, only at pH range, 10. So to maintain this pH range we are using one of the buffer solution. That buffer solution is ammonium chloride and ammonium hydroxide buffer. So this ammonium chloride and ammonium hydroxide is maintaining the pH range 10. Now to determine the equivalent point is nothing but end point. We are using one of the indicator, that is the areochrome black tea indicator. It forms an unstable complex with calcium plus 2 and magnesium plus 2 ions in the water sample at pH range 10. But when this unstable complex is titrating with EDTA, it combines with the free metal ions, that means calcium plus 2 and magnesium plus 2, and it is leaving the free indicator, that is EBT indicator. So let us see this explanation in the form of reaction. Your metal ions are nothing but calcium plus 2, magnesium plus 2 ions, initially reacting with EBT to form unstable complex at pH 10. So this is one of the unstable complex, that is metal EBT. This unstable complex is in the wine red color. Now this wine red color is titrating with EDTA till color changes to blue, that is metal EDTA. This metal EDTA is in the blue color. So now let us see the preparation of reagents. Preparation of reagents. So there are 4 chemicals involving in this reaction, but before that already we have seen 3 chemicals. One is EDTA, buffer solution, EBT indicator. and one more chemical is standard hard water. Standard hard water is preparing for standardizing EDTA. But before that, standard hard water is nothing but whose hardness is known, but whereas EDTA hardness is unknown. So to find the hardness of EDTA, we are preparing standard hard water samples. So these are the 4 chemicals we are preparing in this experiment. The first chemical is preparation of standard hard water. Second chemical, preparation of EDTA. Third chemical, preparation of buffer solution. And the last chemical is preparation of EBT indicator. Now for preparing standard hard water, initially we are dissolving 1 gram of pure calcium carbonate in minimum quantity of dilute hydrochloric acid and evaporating it to dryness on a water bath. So initially what we are doing, we are weighing 1 gram of pure calcium carbonate and a minimum quantity of dilute hydrochloric acid. This mixture is taken in the beaker or the china dish, and this china dish is placing on the water bath until it is evaporating. After evaporating, the dried calcium carbonate is dissolving in 1 liter of the distilled water. So now here every ml of the standard hard water is containing 1 mg of calcium carbonate. Each ml of the standard hard water containing 1 mg of calcium carbonate equivalent hardness. So that is the relation between standard hard water and the calcium carbonate equivalence. So here hardness is expressed in terms of calcium carbonate equivalence. So the standard hard water hardness is expressed in terms of calcium carbonate equivalency. So now the second chemical, preparation of EDTA solution. For preparing EDTA solution, initially weighing 4 grams of EDTA, and in this we are adding 0.1 gram of magnesium chloride, and this mixture is dissolving in 1 liter of the distilled water. Now the third chemical, buffer solution preparation. For preparing buffer solution, adding 67.5 grams of ammonium chloride to 570 ml of concentrated ammonia solution, and this mixture is diluting to 1 liter by using distilled water. And the last chemical, preparation of EBT indicator. For preparing EBT indicator, dissolve 0.5 grams of EBT in 100 ml of alcohol. Here alcohol is maybe methanol or ethanol. You can use any of these 2 alcohols for preparing Eriochrome black tea indicator. So now these are the chemicals preparation. Now let us see the experimental procedure. In the experimental procedure, totally we are having 4 steps. One is standardization of EDTA, estimation of total hardness, estimation of permanent hardness, and estimation of temporary hardness. But the first 3 steps we are doing practically, and the last 4th step we are doing by using relationship that we will see in the next slides. But first chemical is standardization of EDTA. Already I explained what is meant by standardization. Standardization of EDTA is nothing but knowing the hardness of EDTA sample. But how we are finding the hardness of EDTA? Already we have prepared standard hard water. Standard hard water is using to find the hardness of EDTA sample. So initially the given EDTA is filling in the burette, and after that pipetting 50 ml of standard hard water into a clean conical flask and adding 10 ml of buffer solution, 3 to 4 drops of Eriochrome black tea indicator in the conical flask. So after adding buffer solution and the indicator, we will get a wine red color complex which is unstable. This wine red color complex is titrating with EDTA till color changes to blue. So this is the procedure of the titration. So now let us assume the EDTA volume consumed is V1 ml. That means initially we have taken 50 ml of standard hard water. This 50 ml of standard hard water is consuming V1 ml of EDTA. So 50 ml of standard hard water is equals to V1 ml of EDTA. But already we know how to find out hardness in terms of calcium carbonate equivalence. 1 ml of standard hard water is equals to 1 mg of calcium carbonate equivalence. That already we have seen in the chemical preparation. So 1 ml is equals to 1 mg of calcium carbonate equivalents means 50 ml is equals to 50 mg of calcium carbonate equivalents. So in the place of 50 ml of standard hard water, we can convert into hardness. That means we can write 50 mg of calcium carbonate equivalents, which is also equals to V1 ml of EDTA. But we need for 1 ml of EDTA. For V1 ml 50 mg, for 1 ml, this V1 goes to the denominator. So for 1 ml of EDTA, we will get 50 by V1 mg of calcium carbonate equivalents. So remember this relationship. This will be useful in the next 2 slides. So 1 ml of EDTA is equals to 50 by V1 mg of calcium carbonate equivalents. So now what is the second step? In the second step, we are estimating total hardness of given water sample. Given water sample is any kind of water sample we can use here. For any kind of water sample, we can find the hardness by using EDTA method. But in this, we are assuming tap water is a sample water here. So we are finding the hardness of sample water, that is the tap water. So to find the total hardness, already we have taken EDTA in the burette. So in every step, EDTA is taken in the burette only. So now pipetting 50 ml of tap water, that is the water sample in the conical flask, adding 10 ml of buffer solution and 3 to 4 drops of indicator. So we will get a wine red color complex. This wine red color complex is titrating against with EDTA till color changes to blue. So now let us assume the consumed volume of EDTA is V2 ml. So we have taken 50 ml of tap water. Tap water is nothing but hard water. For 50 ml of hard water, V2 ml EDTA is consuming. But from the first step, we know that for 1 ml of EDTA, 50 by V1 mg of calcium carbonate. For 2 ml, we can write 50 by V1 into 2. For 3 ml, we can write 50 by V1 into 3. For V2 ml, we can write 50 by V1 into V2 mg of calcium carbonate equivalents. That is for 50 ml of sample water. But we are calculating for 1000 ml. That means for 1 liter we are calculating for 1000 ml of hard water. In the place of 50 we will get 1000. So for 1000 ml of hard water, 1000 by V1 into V2. 1000 by V1 into V2. Simply we can write V2 by V1 into 1000. So this is equals to milligram per liter. 1000 ml means 1 liter. Milligram per liter is also equals to ppm. So total hardness formula is V2 by V1 into 1000 ppm. So now let us see the next step, that is estimation of permanent hardness. For estimating permanent hardness, initially we are taking around 250 ml of tap water, that is a hard water sample, into a large beaker and boiling it to 1/3 of its original volume. So 250 ml is reducing to 1/3 volume. Until reduces to 1/3 volume, we have to boil that water. And after boiling, all the temporary hardness causing agents are evaporating. Only permanent hardness causing agents will be remains in the water sample. So we are finding only permanent hardness. Because of that reason, we are removing temporary hardness causing agents by boiling. So all the bicarbonates are precipitated as carbonates. So this we have to filter. These carbonates we have to filter. So after filtering, we will get the completely boiled water. This boiled water is taken in the 250 ml volumetric flask. After transferring into 250 ml volumetric flask, this is make up to the mark in 250 ml volumetric flask by using distilled water. So now from 250 ml volumetric flask, pipette of 50 ml of water sample and add 10 ml of buffer solution and 3 to 4 drops of EBT indicator. Same like previous steps. So now titrate it with EDTA till color changes to blue. So now let us assume the EDTA volume consumed is V3 ml. So for 50 ml of hard water sample, V3 ml of EDTA is consumed. But from the first step, 1 ml of EDTA, 50 by V1 mg of calcium carbonate equivalents. So for V3 ml, we can write V3 into, in the place of 1 ml, we can write 50 by V1. So V3 into 50 by V1 mg of calcium carbonate equivalent. This is for 50 ml of water sample, but we need to calculate for 1000 ml of water sample. So for 1000 ml of water sample, we can write 1000 by V1 into V3 mg of calcium carbonate equivalent. So we can write simply V3 by V1 into 1000 ppm. I said now ppm is also equals to milligram per liter. So in the place of milligram per liter, mg per liter, we can write ppm. So total hardness we got V3 by V1. Sorry, not total hardness. This is the permanent hardness. Permanent hardness we got V3 by V1. So already we got total hardness V2 by V1 into 1000. So from total hardness, that means from step 2, if we remove step 3 value. So what is total hardness? V2 by V1. So what is permanent hardness? V3 by V1. So 1000 into V2 by V1 minus 1000 into V3 by V1. So we will get temporary hardness in the given water sample. So this is estimation of total, temporary, permanent hardness of water sample by using EDTA method. Thank you.